Okay, well, people are still joining, but it's 12:30, so I'll start. Just with the normal reminders that well, that's sections 1.8 and 1.9 for Friday. I'm sorry, for Thursday. And then again, don't forget about the quiz. There's a WebAssign based on today's material, 1.6 and 1.7, and that'll be due at the what's now the normal time on Sunday. So Sunday, 11:59. We'll have an exam soon where we'll probably have, I think it's on the schedule for the 7th week, but I will announce that probably this Thursday, but maybe Tuesday. But you'll have plenty of time to prepare, and we'll talk about what the exam will cover. I'll be really clear on that, or as clear as I can be. And then the projects, I noticed that a lot of people had turned them in. I preferred to have them in before class today, but if you're still working on them, that's okay. If you have any last minute questions, that's okay. If there's any issues that prevent turning it in, just please let me know beforehand so we can discuss that. In general, I don't like surprises. I kind of like to know if there's an issue, I'd like to know about it. And just, in terms of the class, it looks like everybody's pretty much into the routine now, which is good. So before I begin, are there any questions about anything? I'm going to talk about symmetry, and then we'll talk about the handout will be about what we had the videos on. But before I do that, any questions about anything? You can either do it through the chat, or you can unmute yourself and just ask. And I'll pause for a second to give you time to ask a question if you have it. Oh, about where to turn it in, just email the project to me. That's the easiest way to get it to me. And again, one project for each group. So, and then once I get all the projects up, sorry, I just sent some messages that were supposed to be to everybody to one person. I apologize. I forgot to change the settings, so let me resend those messages. So email me I just wanted to remind you can email me the projects. And one for each group. Okay. Okay. I think we're okay with questions. What I wanted to talk a little bit about, which I sent an email about it, and I didn't really talk about it too much. I talked about it in one of the videos, but I wanted to talk a little bit more about symmetries, because there's a couple of questions on WebAssign about it. And I want to make sure that you can, that you'll be able to answer them. And there's three kinds of symmetries that we're concerned with. One, I'm just using a parabola that goes through the origin as an example. And that's where things are the same on each side of the y-axis. And that's y-axis symmetry. And I think of that as a mirror image. Can also think about it that if I were to like flip that graph and twirl it around, it would when it came to rest, no matter which side it came on, it would be the same, because it's on the same on both sides of the axis. And then we have x-axis symmetry, and that's exactly the same thing, except it's the same on each side of the x-axis. It's not a very good curve, but imagine these two are the same. So it's a reflection across the x-axis. And notice if it's symmetric to the x-axis, do you notice anything about that in terms of functions or not being a function? And again, you can shoot it out in an email, or you can, in a message, or you can just, unmute yourself and say it. So when you have something that's symmetric to the x-axis, what does that have to do with functions? Can you say anything about whether that's a function or not? And think about the vertical line test. Exactly right. It's not a function because if I do a vertical line, it's going to fail the vertical line test. I want to move this graph. Okay. So again, the x-axis, we're not going to, we don't use this as much because we're concerned with functions, and that's not really a function. Okay. And then you have symmetric with respect to the origin, or origin symmetry. And the way I think about that, that whatever the graph is here, if I flip it over, it would be the same over here. So it's like what I'm doing is I'm just flipping the graph over 180 and rotating it around. And like, so these sides are the same. And I'll go into a little bit more about why that's to the origin. Here, both of these sides are the same. Here, both of these sides are the same. Here, this is the same as this, except it's turned the other way. Okay, so those are the three kinds. And what we're going to see is that this is an even function. So if it's y-axis symmetry, it's going to be an even function. And if it's symmetric with the origin, it's going to be odd. And I'll talk about each of those with an example. Oh, sorry, I didn't see that somebody was waiting. Okay. Sorry, I didn't see that you were waiting, so just let you in. Okay. Okay, so first I'm going to look at, when I look at the examples, I'm not going to worry too much about this because it's not a function. I'm going to look at this one and that one. And again, so a perfect example of an x-axis symmetry is y equal x squared. Sorry, y-axis symmetry. And you can say it's symmetric to the y-axis, or the graph is reflected across the y-axis and it's the same. These all mean the same things. And here's what really makes it, if the graphs are the same, and we'll think of this as an example, I'm going to plug in 2. Over here, I get 2, 4. If I plug in -2, I get the same answer. So in terms of algebra, if xy is on the graph, for example, 2, 4, so is -xy, -2, 4. So again, those are the same y. And notice, if we look at f of x, we get y. And if we look at f of -x, we get the same y. And so this, we end up with this, which means f of x is equal to f of -x, and that's our definition of even. So to say that a function is symmetric to the y-axis is all the same as saying it's even. They mean exactly the same thing. That's kind of a geometrical view. This is an algebra view. This, we look at the graph to see it. Here, even, we look at the function values to see it. Okay. So even an even function, y-axis symmetry, that means the same thing. So questions about that? I'm going to do the same thing with symmetric with respect to the origin. And then we'll go into the handout. Okay, so again, I'll give you a little bit of time to ask questions, and if not, then I'll go on. Yeah, somebody's, sorry, somebody had a private question. I want to respond to it. Somebody asked if this was on the video, and yes, I did talk about this with the video, but I didn't talk about y-axis symmetry with the origin. So I wanted to talk about them both together because they're related. That's the difference. I did cover what I just talked about in a video, but I didn't talk about I didn't cover what I'm going to talk about next. Okay. So when you notice, this stuff is talked about in the book. So if you read the chapter, you'll see that it's talked about here. And this is going to be an example of something that's symmetric. Sorry, my spelling's horrible. With respect to the origin, or you call it symmetric to the origin. These all mean the same thing. And we're going to see that it's going to be an odd function. So it's the same on each side of the origin. I kind of have to show you what that means. And we're going to see that this is an odd function. So this is y equal x cubed. So the cubing function. And the graph on the other side is going to be as if I just rotated this. So it's going to look like this. So that's what I mean. This piece of the graph is the same as this, but it's been rotated. And notice that I'm going to just do a couple of points. If we have the point 1, 1 on the graph, and if I plug in -1, I get the opposite point. So the opposite x gives you the opposite y. If I plug in 2 and cube it, I get 8. If I plug in -2 and cube it, I get -8. So what you say that if xy is on the graph, so is -x minus y. So those are opposite points. So in other words, if xy on graph, so is its opposite point -x minus y. Notice here, this gives us f of x equals y. Over here, this says f of -x equals -y. And if I compare these two, if I look at -f of -x, so minus this, I'm going to get -y, a double minus y, which is y. And y is the same as f of x. So we get negative f of -x is equal to f of x. And that's our definition of an odd function. So again, that's what I didn't go over before. I just wanted to go over this now. Okay, again, there's a couple of questions on WebAssign. And on the handout, I'm gonna informally ask you what the symmetries are there. So if you look at a graph, you want to be able to see if it's symmetric to the x-axis, so the same on either side, or symmetric to the origin. I'm sorry, symmetric to the y-axis, the same on either side of the y-axis, or symmetric to the origin. It has this relation that this piece of it is the same as this piece, but rotated. Okay. Okay, so questions about that? Okay. I'll leave that up for a second if you want to look at it. Okay, so what I'm going to do next is just, you want to get handout number 7 from Blackboard. So make sure that you have that. And I'm going to form random groups today. I just sort of have a question for you before I do, and you can respond in chat, or you can say something out. And I don't want to incriminate anybody, or you can email me as well. I'm just interested to hear before we set up the next project, which will be, after the next exam. Do you want to keep the same groups, or would you rather have different groups for the project? And different groups gives you other people a chance to work with, to meet more people in the class. The same groups, you're working for somebody that you've already established a relationship with. And it might not matter to you, but if you have a preference, you could let me know. And again, you can do that privately in chat. You can say something about it aloud, or you can email me about that. But before I set up the groups for the next project, I just wanted to hear what you had to say about that. and actually maybe the best thing for me to do is when I send out, after I get all the, after I get everything in, I will maybe ask that in part of the, after I get all the projects in, I'm going to send you a debriefing where you can talk about contributions of each person in the group. And maybe I will ask that as one of the questions. But I want to get everything, all the projects in before I ask that. Okay, what I'm seeing right now, it's a small sample size, but I'm seeing new groups. So again, if you have a strong opinion either way, let me know. Okay, okay. Okay, so thanks. I'll form, right now I'm just going to form random groups and we'll go from there. So I'm just doing the math here. Okay, okay. So we'll have 8 groups today. And again, these will be random groups. And then, so anyway, I'll start them now and then I'll open the rooms. And I'm going to move, a couple of people have 5 groups and a couple of people have 3 because Sam and I are in groups. So I'm just going to move around a couple of things just for a second and then we'll be ready. Okay, I'll form the groups now. Okay, good. Okay, so saying hello to everybody. You should have handout number 7, and it's talking about parent functions and then how you transfer them by adding something to Y or adding something inside of the parentheses. So questions or anything about that?
Yeah, I have one.
Oh, sorry about that. Let me,
You're good.
no. Okay. Anyway, sorry about that.
Yeah, I'm just gonna, oh, never mind. So for question, like, I have like for 4, 6, 7, and 8, I guess I don't really understand, like if we're looking at 4, I guess I don't really know what it wants, or even like for 6, like h of x equals f of x minus 5.
Right.
Like which one are we considering f of x?
You'll be
I'm just
using,
getting confused.
okay, so look at number 5, it defines f of x.
Uh-huh. Okay, so that one for 6.
So you'll use the same f of x in number 6. So for number 5, 6, 7, and 8, 5, 6.
Okay, it's all square root.
Yeah. Okay, I should have been clear about that. Yeah. So once
okay.
yeah. Does that make sense?
I think so. So
Yeah.
for 4, are we using x squared still?
So mx, it says h of minus x. And part of this is just to work with the notation. So you have to look up to number 2 and it tells you what h of x is.
Yeah, so okay.
So that's the h of x you'd use. So like in number 2, you'd want to write down what h of x is. So then when you get to number 4, you know that you're going to just plug in the minus x.
Okay.
Okay, and it's confusing, I know, but function notation is confusing, and I'm doing it this way because you have time to ask questions, and it's also to sort of, I don't know, it's my view of trying to help you get used to the notation. And so each time that you change a function by adding to it or subtracting it or multiplying it, you're creating a new function, and that's why I'm using so many different names, because each function's a little bit different. Okay.
Okay, I think that makes sense. Okay,
Yeah, and that's
thank
part
you.
of, and that's part of the thing, and that's something I can help you with too.
Mm-hmm.
Okay.
Okay, sounds good.
Okay. So other questions? And again, I encourage you to, like when you're working with the groups, I think it builds better working environment if you can have your cameras on. I know that there's reasons not to, but if you can have it on, I really encourage you to do so. I think it helps your group members interact with you. Okay, I'll be back. And then again, if you have a question, you can ping me. And I'm just going to go and visit the other groups. Not sure if there's any more questions.
Thank you.
Okay, you're welcome. Hi, sorry, I'm interrupting you all. Any questions? Shoot. Oh, you're hearing me okay? Yeah, good, yeah, okay. Okay, there's a lot of notation. So like when I talk about number 2 and 3, when I talk about f of x, I'm talking to the f of x from number 1. And then also when I get to 6 and 5 and 6, or I'm sorry, 6 and 7, I start talking about f of x. I'm referring to the new one we defined in number 5. Okay, and so there's lots of questions that have to do with the notation. And so part of what I'm trying to do here is get you used to that notation. So just let me know if you have any questions. Okay.
With these, are we talking just about a linear function being f of x?
No, because if
Like
you
we're
look
just
at
using,
if you
I'm
look at
sorry.
number 1, it says y is equal to x squared.
Oh, that's not linear.
Okay.
Yeah, you're right.
And then number 2, it would be, so h of x would now be f of x, x squared plus 4. And so what I'm trying to, the function notation is, it's challenging. I'm trying to get you used to it. So that's part of this, is just about working through the notation. Okay. Does that make sense? Good.
Yeah, thank
Good.
you.
Okay, other questions? And again, happy to see some people with the cameras on. I really think that helps everybody if you can keep them on. I understand there's reasons not to sometimes. So I'm just putting that out there. Okay. Okay, so I'll take off unless if there's another question. And if you have one after I leave, just ping me. Okay, see you all later. Sorry, I'm just checking in to see how you all are doing. If there's any questions?
No, we were doing it all individually first, and we were going to come back together and discuss it.
Okay. So the notations are clear and everything like that? Do you have any questions? Yeah. Okay. Yeah, just ping me if you have any questions. Otherwise, I'll be back and see you later.
Okay, thank you.
Okay.
Thank you.
You're welcome. Yep, bye-bye.
Wait, I think you're on mute. You're on mute, Professor.
I know. Okay,
And
thanks.
Sydney, I think you're on mute too.
Can you
Maybe.
hear me?
Yeah, I can hear you now.
Thanks. Okay. Any
You can
questions?
hear me now?
Yeah, you're good.
Okay.
Professor, I wasn't sure if this one was even or odd.
Oh, which one? The first one?
Yeah, we're on number 3. Can you see my screen?
Yeah, I can see you.
Oh, you can't see. I'm sharing my screen right now.
Okay.
I can stop share and then I can share it again.
That might have been that I wasn't on it when I came in. Now, okay, good, perfect, yeah.
Yeah.
Okay, so if you, can you see a line, a place where that's symmetric? It's the right graph. Like if you divide it, like notice where the bottom is. I don't know, can you see me moving the cursor? Okay.
No.
Yeah, so right there, that's the line of symmetry. If you go, if you extend that line, that's what it's symmetric to.
Yeah.
Okay.
Not the origin. And then the other thing too is that, remember, it would have to be if, let's say, if you look at the point 4, it goes, the x coordinate 4 goes to 4.5 for the y coordinate.
Mm,
So f of 4 is equal to, yeah, just move it over to the up to where you get x equals 4.
oh, right here?
No, that's right there. Yeah. Okay, good. Yeah. Okay. So it's hard to get exactly 4, but it's going to be 4, 5, right?
Yeah.
Now,
Yeah.
if it were odd, if it were even, it would have to be -4, 5.
Okay.
And that's the only way that you get that symmetry. Only an even function has symmetry to the y-axis.
Mhm.
Okay, so it can't be symmetric to the y-axis. The other two were, but this one's
Mhm.
not, because it's not
Yeah.
centered there. And then it can't be symmetric to the origin because there's nothing negative.
Right. So it's odd?
No, it's neither.
Oh, neither. Sorry. Okay.
Right. It's not even, it's not odd, so it's not. Those are the 3 choices. And most
Okay,
times,
because that's what we had. I think that's what we came to consensus, but on the worksheet, it just said even or odd, so we weren't sure if it could be neither.
oh, well, the answer would be, you're right. I should have said or neither, but the
Yeah,
answer,
no, it's okay.
the
No, you're
answer
fine.
would have been neither. No, you would have said, no, it's not even or odd, you know.
Yeah.
But I didn't say it as well as I could have, but yeah,
So then for what are symmetries? What did we put? None?
none. Yeah.
Okay.
Because even or odd is where you find out the symmetry. So the answer to D, if it's even, it would be symmetric to the y-axis. Odd,
Mhm.
symmetric to the origin. Neither, no symmetries.
Okay.
I mean, there's technically a symmetry to x equal 3, but I'm not asking that question.
Okay.
Okay.
Awesome. I think that's all we had. Thank you.
You're good with the notation?
The notation?
Yeah.
Mm-hmm.
Good, because one of the things, it's a little challenging notation-wise for some of the groups. I'm glad to hear that you don't have questions about that yet.
Yeah.
Okay, good. Okay. And glad to
Thank
see your
you.
cameras are on too.
Yeah.
I think you work together better when they're on, so.
Yeah.
Okay, so I'll leave you be.
Thank you.
Just let me know if you have another question, or if before I leave you have a question, just shout it out.
Okay.
Okay,
Cool.
bye-bye.
Bye.
Wait.
I'm just gonna keep. Oh. Hello. We can't hear you. There we go.
Yeah, no, I put auto mute on today, which I usually don't do, but okay.
I had a question about number 3
Okay,
and the range.
okay.
Does the left side of the graph go into the negative?
Yeah. So if you plug in a negative number, like let's say you plug in like -100, you would have, it would be 100 minus 3 squared plus 4. So it would be a really large number. Okay. And remember, a parabola, it's that U-shaped, like the parabola kind, it goes on forever like that.
Right. Okay. So it's not like the cubed where it never touches the axis. It'll go across.
Well, the cube keeps going up and up and up too, but it goes up on either. Oh yeah, it never goes across the x-axis, right? It's always going to be that bottom of the U is the lowest point in the range.
Oh, I was sorry. I meant to say the reciprocal one, not the cubed.
Okay, yes.
But yes, I got it now.
Okay, good. Okay, got it. Okay. And Stone, are you there? I know you got kicked out, it looked like, and then we're trying to come back.
Yeah, I'm good now.
You're back?
I'm
Okay,
good
good.
now.
I know it seems like every class there's a couple of people that happens to.
Yeah, I know, it was weird.
Yeah, so sorry about that.
All good.
Okay, other questions before I go?
I guess I'm a little confused on number 4.
Okay. Now, oh, go ahead.
Oh, you can go.
No, I was anticipating your question, but that's not a good thing. I should listen to your question.
Well, I don't know if I have a good question. I'm
Okay.
just confused on.
Okay, good.
Yeah.
Not good that you're confused, but good that I understand what you're saying. Okay. Okay. So for number 4, each time you change a function, you have to give it a new name. So when I look at h of minus x, whatever h is, I have to give it a new name, technically. Okay. So I'm looking at h of minus x. Okay. So that means, okay, so you go back up and you look and see what h was. And you look to number 2 and you see that h is x squared plus 4. Does that make sense? I look at number 2, that's where this is coming from. Does that make sense? And then so m of x would be h of x with every x replaced by a negative. And remember, I'm squaring the minus x plus 4. And so does that change anything?
Oh, sorry, I was on mute.
Yeah.
Yes.
Let's see, minus x squared is still x squared, right?
Right.
Mhm. Okay. Oh my gosh, sorry.
Yeah. So it doesn't change h at all. And does anybody want to give me a guess as to why it doesn't change h? Because h is symmetric to the y-axis, therefore it's even. And since it's
Then it
even,
would-
h of x is the same as h of minus x.
Right.
Okay, and so that's what I'm trying to get people to think about. It's complicated, but that's kind of what I'm trying to think. So this is the same. So in other words, we're saying that this is equal to h of x. So we started off, this is what h of minus x was that's how we were defining m of x. That tells us to plug minus x into h. We do that and we get h. And remember that because h is even, you get the same thing if you put in minus x or plus x because of the squaring.
Okay. Thank
Okay.
you.
Okay, and the same for n. I would just go through the same process for n. You have to go back, it says to go back to g, so go back to what g is and then figure out what n is from there.
Okay.
Okay, and again, this is just, I'm trying to get people used to this weird notation. And technically each time you change a function, you should give it a new name. So that's kind of that's kind of my thought process here.
Okay. Thank you.
Okay. So I'm going to head out unless if there's questions. I'll unshare.
I think we're good other than that.
Okay, good. Okay. So let me know if you have other questions. See you in a bit.
Thank
Yep.
you.
Bye-bye. I'm just checking in to see how everybody's doing, if there's any questions.
I had one question.
Sure.
On number 4, I'm pretty sure. Yeah, on number 4. Actually, just for all of them, how do you tell if they're even or odd?
Okay, there's a couple of ways. I'm going to share the screen.
Okay.
So let's look at number 2, okay? And number 2 is h of x. And it's x squared plus 4. Now I'm going to do it by hand, but if you graph it using Desmos, you'll see the same thing. The graph looks like this. It's the graph of x squared. So I'm just trying to moved up 4. So it looks like that.
Right.
Okay, and if I look on each side of the axis, it looks to be the same. Each side of the y-axis. So it's they're mirror images of each other.
Okay.
So that's one way. And then I could test, and I'm just going to do a test of 2. If I plug in 2, I get 2 squared plus 4, 2 squared plus 4, which is 8. And if I plug in minus 2, I get minus 2 squared, which is 4, but I also get 8. So I get the same thing for plus minus 2 as I do for plus 2. And that's going to be the same. That's going to be the same for any x value. If I plug in minus 3, I would get minus 3 squared, which is 9, plus 4, which is 13. If I plug in plus 3, I would get 313. So I get the same value. So h is the same. Sorry, that's supposed to be an x. For x and minus x. In other words, h of minus x is equal to h of x. Okay, so are you with me that far? I can go back over stuff.
Yeah, I got it.
Okay, and this is the definition of even when that happens.
Mm-hmm.
And even functions are symmetric to the y-axis. They mean the same thing. So if I say a function's even, it's symmetric to the y-axis. And if I say a function is symmetric to the y-axis, it's even. And that's because if I draw a vertical line, a horizontal line across this function, whatever I get for this x value is going to be the same as I get for this x value, which is negative x. Because that's the way a parabola works. Yeah. So these things mean once you get this, you can say it's even, and that gives you this, and vice versa. Once you see it's symmetric to the y-axis, you know it's even, and you know that's true. So they all mean the same thing.
Okay.
Okay.
Other than that, I'm pretty much
good. Okay. Other questions? I think somebody might have gotten kicked out again. I know it's been happening today. Okay, so I'll stop the share, and then if you have any other questions, just let me know.
What time do you think you're going to pull us all back, or what time do you think we're going to wrap up?
What are you on right now? What problem?
I am on problem number 5.
5. How about the rest of the group?
Working on 6, moving on to
Okay.
7.
Okay, so it looks like I'm going to check in about 1:30. It looks like you all will be done about then. And so probably somewhere around 1:30.
All right, thank you.
Okay, you're welcome. Yep, bye-bye.
So x squared would, so just
very, very simple. X squared would be symmetrical, and that's an even function. X to the third would be an odd.
So one of like, oh, this is confusing. So one is h in parentheses negative x, and the other one is negative g, and then in parentheses positive x.
I'm
So-
gonna stop my share for you guys. There you go.
Like,
Oh, he's in here. You want to ask him a question?
So
No, professor's in here.
Yeah.
yeah.
Yeah, I was gonna see if you had any questions. So if you have it,
Number 4.
okay. And again, it's not I'm not trying to be tricky on purpose, but the notation is weird, and so I'm trying to get
Yes.
used to the notation. So is the question about like when I write something like this?
How to write it in like the y equals, so we can plug it in. So we can plug it in the decimals to show the line.
Okay, good. Okay, so that's what I'm writing, right?
Yes.
Yes.
Okay. Well, I have to go up to number 2 to see what h is, and I'll answer your question. And h.
Oh, I didn't know. Okay.
Right. And that I should have been clearer about that, but yeah, it's the idea is that if I say h of x, you look to the last h of x.
So that would be the f parentheses x plus 4.
Right.
Okay.
Okay. And so that. Oh, go ahead. Sorry.
So if we did y equals x plus 4.
That's what it's going to be, x squared plus 4. So m of x, that's what y is.
Yeah, got that.
And that tells you, for m, it tells you to plug in minus x wherever you see an x. And h.
So negative x squared plus 4.
Exactly.
Okay.
But what happens when you square minus x inside the parentheses?
It's just x squared.
Yeah.
X.
Okay. Well.
So you've already graphed.
And then do we do the same thing for the g of x?
Yes, exactly. Right.
Well, okay, but like, what's the difference between like for one, the first letter is a negative, and for the other one, the x is negative? Are you just saying like you want the x in parentheses and negative? Would you say negative x?
Right. So here we have n of x, and that's defined as negative g of x. So you have to go up to g of x.
Which is the parentheses x minus 3 squared plus 4. So you turn that whole thing to a negative.
Exactly.
So it'd be negative x minus 3 squared plus 4.
Well, negative, here, let me write it out this way. It's negative the whole function.
Oh, the whole thing all the way across? Okay, cool.
Because g of x is what's between the brackets. So the way I'm thinking about it is like this. And then I put whatever g of x is here, and then I make everything negative.
Okay.
So to simplify writing it out, so the plus would be a negative 4, right?
Yes.
Okay, cool.
Yeah. Okay. And so that's just going to move the axis. It's going to be the opposite, but it's going to be what was below the x-axis before is now above the x-axis, but nothing was below. What was above the x-axis is now below.
So it's the inverse.
Yeah, it's called, they say you're reflecting it across the x-axis.
Flip it over the x. Yeah.
Okay, it's like what was negative is positive, what was positive is negative.
Okay.
And that just flips it. It's like if you had the graph and you could just flip it over the x-axis, that's what you would get. Okay. And what I'm trying to do is get you used to this notation. So it is convoluted, but I'm trying to give you practice with that.
Okay.
Okay. Okay, does that help?
Yeah, I'm trying to graph it. So the negative, so when I'm graphing the first one, it would be negative x squared plus 4, right?
You mean m of x?
Yeah, to show the reflection.
No, because it doesn't get, because it's, since the graph, look, what we get here is we end up getting that, this is h of minus x, right?
Yeah.
But when we plug it in, we get the same as h of x.
Okay, it's just the same. It's no
Right.
different.
Right.
Okay.
And that's because h of x is an even function.
Okay, that makes sense.
Yeah. Yeah. It's convoluted. I'm trying to get used to these ideas. So nothing changes. It's just h of x with a different name. That minus, since you're squaring the minus, it goes away in essence.
Okay.
Okay. Okay. And then this one, it would just be the same graph you had for number 3, but it would be reflected across the x-axis.
Okay, perfect.
Okay.
Do we want to ask about the even or odd question for number 3 and 2? Because I think we were trying to discuss whether it was even or odd or neither.
I'm okay with what we have, but we can always ask him if you want.
Did you get neither for number 3?
Yes, for both.
Yeah, it's neither for number 3. For number oh, go ahead.
What's like the reasoning behind that? Like what would make it neither?
Well, the graph, it's not, this is what the graph looks like, right? For number 3.
Yeah.
Yeah.
Mm-hmm.
Now here's, if you look at a parabola, it's going to be the same on both sides of the bottom point.
Mm.
So it really what it's symmetric to is this line, whatever that is.
Yeah.
Okay. But it's not symmetric. It's not the same on both sides of the y-axis. So it's not even.
Yeah.
And then
Okay.
it's not this part over here isn't the same as this part because there's nothing over here. So it can't be odd. So it's neither.
Okay.
For 2 or 3?
3.
Okay, so what we had decided.
Yeah. And number 2, it's number 1 is even, y equals x squared, and you're just moving it up along the axis. So it really doesn't change the fact that it's even. Yeah. It just moves it up. You still have the y-axis as the line of symmetry. It's the same on either side of the y-axis, whether it's y equal x squared or y equal x squared plus 4.
So then 1 through 3 is for number E for the symmetry question. It's all y-axis.
Number 1 is y-axis. Number 2 is y-axis. Number 3 is neither.
Okay.
Neither y-axis or origin.
Okay.
Okay.
That's what I wrote down that we decided on.
Yeah. Remember, even is the same as y-axis symmetry. Exactly the same thing. So if it's one, it has to be the other. And then symmetric to the origin is the same as being odd. But most functions are neither.
Okay.
Like you're going to look at number 5, 6, and 7. It's the square root function. And that's not going to be symmetric to anything.
Okay.
So that won't be. And since it has no symmetry, it can't be even or odd. Okay. But I'll let you get to that when you get to it. Yeah. Okay. Okay. So questions? Or sure, somebody had a question in another group. Okay. You can always call me back. I'm going to stop the share and then just call me if you have a question. Okay. See you later.
Thank you.
Hey, I saw Quinn. I saw you had a question, or somebody had a question.
Yes, I had a question. So I think we're all finished up. So are we gonna head back to the big group or what?
Yeah, not every group is as far as you are. So if you want to, if you want to take a break, I'll give you like a 5-minute warning or so. I'm thinking more now, like 1:35 or something like that, maybe a little bit later. So you can take a break.
Okay.
And I'll send a message back to everybody so you can, hopefully you'll hear that.
Awesome. Thank you so much.
Okay, you're welcome. Hello, I'm just kind of checking in and seeing if you have questions and seeing where you are on the worksheet.
I finished.
Okay.
Mm-hmm.
How about the others?
Yeah, I'm also done.
Okay.
Yeah, me too.
Getting there, just about.
Well, lean on your fellow group mates, David. That was David, because they got it done, so they can help you, or I can help.
Yeah. No, I'm doing good though. I'm good.
And I'm going to see where all the groups are. I'm guessing I'm going to call people back about 1:35. So I'll send out a message to everybody. So if you're done and want to relax until that, then that's fine.
Okay, thanks.
Okay, you're welcome. Yep, bye-bye. Hello. Just kind of seeing where you all are and if you have any questions.
I'm about done. I'm on the last one.
Okay. How about the rest of you? Any questions, or where are you? I'm trying to think when to call people back. It's looking at about 1:35 now. That's what I'm estimating.
I'm on number 7.
Okay. Questions?
Yeah, I'm on the last one.
Okay, good. Questions about any of them? Okay. Okay, so I'll see you. Call me back if you have a question. And about 1:35, I'll send a message out, letting you know that I'm calling everybody back.
Sounds good.
Okay, see ya. Checking in to see where you are, and if you have any questions.
I think we're about to start going over it soon, and I don't think we have any questions yet.
So you finished, the way you're working on it is separately, so has everybody finished them and now you're going to talk about them?
Yeah, we're going to talk about it.
Yeah, I finished them.
Okay, good. And so I anticipate you're about where other people are, so I anticipate calling the class back about 1:35. So if you get done before then, you can relax for a few minutes. Okay, so I'll see you and let me know if you have questions.
I just put like the square root of negative, and I just put the negative outside the parentheses x minus 3 and then minus 5.
Oh, I meant the negative sign outside of the square root.
Oh, okay. Sorry, that makes sense. No, you're fine. Not your fault. You're good.
Are you doing number 8?
Yes.
Yeah, okay, good.
Okay. I can just graph them both, and then we can just like see what they look like.
Okay.
So just two questions, and then I'll let you finish. It looks like you're near the end. I was going to call everybody back at 1:35. That's not really a question, but I didn't hear you. Sorry.
No, I think there might be something else in the background of someone's.
Oh, okay.
Yeah.
Okay, that happens. And then, so I'll call everybody back about 1:35. And then what did you get for the symmetry properties for 5, 6, and 7, and 8?
We got no symmetry?
Got it. Not odd, not even, no symmetries.
Yeah.
Yeah, good. Okay, good. So I'll see you in a bit. I'll leave you. It looks like you're in good, unless you have any questions. It looks like everybody's doing well.
Yeah.
Okay, good.
Thank you.
Okay, thank you. See you in a bit.
Yeah.
Coming in to bug you all again, and I'm wondering if you have any questions and where you are.
I think we're all on number 8.
Okay.
Just finishing it up.
Okay.
What for the answer B, which is asking. Oh wait, I'm fine with that.
Okay, that's all right. I'm going to call everybody back about 1:35. It looks like everybody's pretty much near the end. So I'll call the group back for kind of a debrief for a few minutes. But so if you get done before, then you can just relax. I'll send a message out. But if there's no questions, I'll just head out.
Okay, thank you.
Okay, you're welcome. Yeah, bye-bye.
Worried. I trust you. Just slightly worried. I may ask Professor Google in a minute.
Professor Google.
I like
Okay.
So questions about anything? I'm just kind of seeing where you are.
I have a question on 5. So
Okay.
you say the parent function is y equals square root x.
Right.
So would that, in terms of like Desmos, would we plug that in as our parent function and then go from there?
Yeah, so h of x, sorry, you can't see what I'm writing. I'll do it on I'll just write it. So I think it's easier if I do it. I forgot I don't have the document camera here. Okay, so the thought process, h of x.
It doesn't give us an h of x on 5.
5
It just says y equals square root x.
Oh, 5, I'm sorry, yeah. Yeah, so that's your f of x, sorry, that was my fault. I should have said-
Mine just says y equals. Like it doesn't say anything after that.
I know, I should have put f of x there, and that's my mistake. So that's what I meant to say, is this. All I said was y equal, I forgot that.
So it's supposed, okay.
So,
yeah.
Oops.
So f of x equals y.
So f of x equals y equals square root x.
Yeah.
Okay, perfect.
Good, yeah. Okay, does that answer your question?
It answers mine, it does, yeah.
Okay.
And then I had a quick question on
Sure.
on stuff. So when we're doing like increasing and decreasing, can we say something like -4, comma, negative infinity, or does a negative infinity always have to come first in the parenthesis?
Yeah, the number line actually goes from left to right, so minus infinity is over here. I may not be getting your question right. Infinity would be over here, and so if this is -4, when you write an interval, what's on the left is always the lowest one. Is that what your question was?
Yeah, so
that's what you would write as this. If you're saying it's decreasing or increasing from minus infinity to -4, that's how you'd write it.
Yeah.
Okay.
Okay.
That's right.
So it's always goes from left to right.
Okay, that's what I thought. It's just kind of confusing because like technically like it starts decreasing at like the -4 and then it goes down.
Yeah, so which one is this number
4? 4 B is B, I think.
Yeah, so what would be which one, n of x or m of x?
N of x, I think.
N of x looks like this, right? It's going to be minus x squared minus 4.
No, that's the negative brackets.
Yes.
And then in parentheses, x minus 3 squared
Got it.
plus 4.
So this one, right?
Yes.
Okay. And that's supposed to be an n. So this is, so g of x looks like this, right? And that's 4 right there.
Yes.
Okay. Then h of x is going to look like this. And it's hard because we don't see the whole graph.
Yeah, like that.
Right.
My Zoom froze. Yes, okay.
Right.
And so
it's going to be increasing from minus infinity, it's going up
to
4. This is where it's increasing.
I think it's technically -4, but yeah.
No, because isn't it y? Sorry, let me erase this.
It's at the y is at -4. That's its maximum is negative.
Remember I got it. Okay, and this is 3 right here. Sorry, that should be a 3. I made things worse. you keep track by the x-axis, by the x point, not the y point.
So it'd be 3.
It would be 3, yeah. And yeah, I was just, yeah. So it would be 3, because this is the point. It reaches the height when x is equal to 3. In these intervals, you always do it in terms of x's.
Yeah, we'd been keeping track of the y this whole time.
Right. But yeah, the way you do it is keep track of the x's.
Okay.
Right. Because it's sort of like when you talk about a function and increasing and decreasing, the way to keep track of it is just by the x's, not the y's.
Okay.
So the y coordinates, I agree, go from -infinity to -4, and that's while the x and the x coordinates go from -infinity to -3. Okay.
I have one question for you. I jumped ahead a little bit because 5 is really basic. So on 6, it's the h of x is equal to the f of x minus 5. So would we use the same data from 2, which is y equals
Oh, no,
h.
I'm sorry. For number 5.
Number 6.
Yeah, number 6. Number 5, that's the new f of x, and I'm sorry about that. The y equal x is now your f of x. So for number 6, this is square root of x minus 5.
Oh, yeah. Okay, that's easy. Thank you.
That was my fault. Yeah.
It's the same thing, but it's just at -5 now.
Perfect. Thank you.
Okay. So I'm going to call everybody back in a couple of minutes. I just wanted to check in with you. And any more questions before I go?
Okay, so I know I'm like beating a dead horse here, but so for 4 increasing, it'd be -infinity, 3, and then for decreasing, it'd also be -infinity, 3.
No, because it decreases over here. Once you get to x equal 3, the function starts to decrease. So the interval that it decreases on is going to be x coordinate 3 to x coordinate infinity. Because if we were walking, if we're walking in this direction, we'd actually be walking down.
Okay.
Okay. And you're not beating a dead horse. I want to make sure you understand it. And the only way to do that is to ask questions.
Okay, thank you.
Okay. Yeah. Okay. Other questions before I go? Okay, good. Okay. Oops. Okay, see you in a bit. I'm going to call everybody back in a couple minutes.
Okay.
Professor, you're muted.
Thank you. I had myself on auto mute, as you all discovered several times, and forgot to unmute. Okay. Okay. So just a couple of overall things. I think people, part of that was getting used to the notation. For number 5, I kind of screwed up and I just wrote y equals square root of x. And what I wrote in my mind's eye was this, but it wasn't on your paper, so you had no way of knowing that. So I apologize for that. That caused some confusion. And part of this was just getting used to function notation. That's why I was using a lot of different letters to sort of challenge you a little bit. And people looked like they did pretty good overall on that. So I was pleased with that. And the kind of the idea was for number 1 through 5. For number 1, we started with y equal x squared. And then we moved it up. And then we moved it over. And then in number 4, you either left it alone or you flipped it over. So the idea was we started with one graph and just did various things with it to change it. And so I was trying to get you to see what the interactions were, like what changes when you move the graph. The shape doesn't, but things like symmetry can change. Like over here, there was no symmetry, not even or odd. The same here. Increasing and decreasing kind of changes a little bit, but the overall pattern is the same. So that's what I was looking for there. And I was going to say something briefly about number 5, 6, 7, 8, but before I do that, any questions? And you can either say them or you can hit them, you know, you can ask them via chat. And I'll post the solutions in a bit too. Okay. How about symmetries? How about number 3 and 4? Were there any symmetries? So again, just number 1 and number 2, they were even, and even is the same as y-axis symmetry. They mean the same thing. And number 3, number 4, well, I think m of x is the same as x squared plus 4, so that was even. But n of x, no symmetry. And then number 3, no symmetry. So, and neither even nor odd. So again, even is the same as y-axis symmetry. Odd, and you didn't have any odd functions, is symmetric to the origin. And neither, it's not y-axis or x-axis. I mean, y-axis or origin. Okay. So questions or comments about that? Oh, I got some new messages, sorry. I missed those. Okay. For number 5 to number 8, there's no symmetries. So neither even or odd. And the idea was you start with the square root, and then we moved it down, and then I think we moved it to the right. So this would 5, 6, 7. I have to double check, but I think we moved it to the right. No, we moved it to the left. So it looks something like this. And then number 8, one of them was that, and then the other one would be sort of the opposite here. Something like that. Okay. So again, it was just trying to see what happens to a graph as you transform it. So, and I'll post all the solutions. And I like the way that people were using Desmos and people are asking good questions in the groups. So I like what I saw today. Okay, so that's what I got. Any questions or anything before I go? And then otherwise, I'll stick around for. Oh, right. I'm just looking at some of the questions. Let me respond to everybody for what I'll do that here. For number 4, we had m of x was h of minus x. That was minus x squared plus 4. That ends up being x squared plus 4. So that's going to just be this graph. So the same as number 2. So that did have y-axis symmetry. N of x, no symmetry. If that makes sense. I know somebody had a question about that. Okay. Okay. I'm not seeing other questions. Again, if you want to stick around and have questions, I'll be happy to answer those. If you didn't get through the worksheet, I'll be happy to work with you on that. Just stick around. Otherwise, you're free to go, unless if there's any last minute questions.
Thank you, Dr. Alexander.
Thank you.
Thank you.
Okay, you're welcome. Have a good afternoon. See you all on Thursday.
Yeah, have a good one.
Thank you.
Bye-bye.
Hey, Professor, did you want
Yes.
to do the meeting here?
Yeah, sure. And we can, I think if we're the only ones here, then we have some, then that's not a problem. I mean, we can do it in my office if you'd prefer, but I don't think, nobody else is here. What would you prefer?
Oh, we can do it here. No
Okay,
problem.
good. In my office, I just mean a different Zoom link.
Okay, I got you.
Good, okay. Yeah, so I'm trying to think. So you were set up for WebAssign, right?
Yeah.
And that was going well. It was the quizzes.
Yeah.
Yeah. And then oh, go ahead, sorry.
I was just saying, I want to say that I missed 2 of them.
Yeah, and then you missed class a couple times too.
Yeah.
Yeah. And I just wanted to check in to make sure, that everything was going okay. And I'm happy. I mean, we can, let's see. You're going to have enough chances to make up quizzes that's not going to hurt your grade.
Okay.
Okay. But I just wanted to make sure that, you weren't having problems like with connection issues or something like that.
Yeah. Yeah, for the most part, I'm pretty good on that. I was telling you, it was a job situation. I kind of got that under control. So on Tuesdays and Thursdays, I won't go in until 4, which is perfectly fine. On the project thing, they were like halfway done with it. I didn't want to just hop in and conclude. So is it okay if I finish it off today and get it in?
Yeah, do it. Yeah, I was going to say that. Just do it on your own. That would be perfect. Okay, and you can. Yeah, if you finish it today, that's fine. If you get it to me tomorrow, that's fine too.
Right.
And if you miss, so you said last week you missed because of the jobs.
Yeah.
I have another class where their connection's horrible, so they never can join the whole class. So we meet privately a lot. So if that happens, if you have to miss a class, just let me know, and that way we can keep in touch about it. I can at least, we can meet, or I can talk to you about what we did in class, or I can send you an outline of what we did, and you can see. But my sense is that for what I did see for you, you were doing okay.
Yeah, for the most part.
Yeah, okay.
Only thing about the last WebAssign, not the one that was due on Sunday, but I want to say the one that was due last Saturday. It was a little tricky for me, but I ended up getting it down, I guess you could say.
Okay. Did you need more time on that? Because
no, I'm okay.
You're okay, because I extended it for a couple of people, gave them some extra time. So if you had, and I'm happy to do that if you needed more time on that one.
Okay.
Yeah.
Well, thank you.
Okay. So just let me know if you do, and if right now I'm hearing that you don't, but if you do want more time, you can just let me know, and I'll open it up for a couple of days.
All righty. Sounds good.
Okay.
All right.
Okay. So otherwise, things are going okay for the class and everything?
Yeah, it's pretty much simple. When I was doing the breakout group, my mic wouldn't work, so I'm not sure what was happening there.
Yeah.
But yeah, I mean, well, I had it somewhere around here. I was just using my sketchbook to write out the answers and stuff.
Oh, okay.
So like with things like that, did you want us to send you that in, or?
You don't need to send me that in. You know, I mean, as long as, but if you have questions about it, if you weren't able to hear or participate, you have questions, I'm happy to answer those.
Okay.
Okay.
I'm saying I'm okay.
Okay.
Yeah.
And then for the classes you missed last week, if you know, if you just want to send in, we had Tuesday we didn't have much work in the class. We were talking about the class and doing a survey. Thursday you can go back and see what the handout is. I think it was handout number 6. If you want to do that and mail it to me,
okay.
then I mean, you know, email it to me or just take a picture, however, and then I'll count that as you being there that day.
Okay. Sounds
Okay.
good. I'll get that
Yeah.
into you before
Yeah.
4.
Okay. And again, you don't have to do everything today. I'm piling a couple things on you, so if it take a few days to get it all set up, that's fine.
Okay. Thank you.
Okay. Okay. Yeah, I just want to. Yeah. Okay. Good. So it sounds like things are okay. And if you know, if not, let me know. You know, if you run into questions or anything, but seems you're doing okay. So.
Alrighty.
Yeah.
Thank
Are
you.
you at Drake or are you elsewhere?
I'm on campus, but I live off campus.
I see.
So.
Because I know on campus there's been some issues, people getting kicked out of the connections don't seem perfect. I was going to say.
Right.
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 I don't think they're perfect anywhere.
Yeah.
Yeah.
I mean, it happens though.
Yeah, it does.
Especially when the same, like, especially when you have a lot of people using the same thing at the same time.
Yeah.
It's gonna mess up. So.
It's like water pressure. If you're in a neighborhood, everybody's using water at the same time. The water pressure goes down. Yeah.
Right. I got you.
Yeah.
But thank you for understanding.
Okay.
So.
Okay. Okay. Well, if you don't have any other questions, that's it. But if you do, I'm happy to answer any.
Gotcha. Thank you again.
Okay. Well, take care, Kay. It's Kai or Kay?
Kai.
Kai. Okay. Okay, Kai. Okay. See you later.
Yeah.
Yeah. Bye-bye.